Hello everyone, welcome to Structural Insights. My name is Shilpa Dikshit and today we are going to discuss crane loads in load combinations. So this is a typical challenging problem. Here we have this crane and this crane is taking support on four wheels, 1, 2, 3 and 4. These four wheels are also shown here, 1, 2, 3 and 4. So crane has typically three movements. First is upside down of the crab. This is a crab. This is a crab. Okay. So this portion I have zoomed here. Okay. So this is a crane trolley and this is a crab. So this crab can move up and down. This is a vertical motion. It can go in lateral direction. This trolley can move in lateral directions, and it can this crane as a whole can move in this direction. This is called as longitudinal direction. Okay. So when we are doing an FE modeling of some building, some warehouse or any industrial building, and we are proposing cranes, so we have to combine the various loads of the crane into the load combinations table. The load combination table is nothing but the one that we refer from IS 800, and from that table we include the various loads of crane. So crane loads are not straightforward. We have to refer IS 800, IS 800 2007. Also we have to refer IS 875 part 2 1987. So these two codes have given the guidelines on how to combine various loads of cranes into load combination table. All right. So what can be the various loads that are there on a building? So let's list out these loads first. Okay. So let's list out all the loads. Number 1, dead load, DL. Number 2, superimposed dead load. Number 3, live loads. Number 4, wind loads. So if it is a steel structure more than 10-meter height, so we also need to consider wind loads. Wind loads in X direction and Y directions. Then we have earthquake loads. So these are there in X, Y and Z directions. Then we have crane loads. Okay. So crane loads, actually from 6, we'll list down the crane loads, and this actually I will just mark it as a heading. And now 6 number. 6, let us assume CRV. CR is crane vertical weed load. 7, CRVI. Here in CRV, there is no impact considered. Okay. Here I stands for impact load. So here we have crane vertical load plus impact. Then 8th, CRHS. Crane lateral surge. So this is lateral. Okay. So this movement we are talking about. Okay. Now 9, CRHL. crane, longitudinal loads. You can say surge as well, okay? Then 10th. 10th is CR, park. Park means parking. So when crane is in parking position, then only we are combining this thing with earthquake or wind loads. So this is the crane loads. With maximum effect. Okay. So let us see first of all, what is this impact? Okay. So let's start with CR. First of all, I think we should better start with CRV only. Okay. CRV. So whenever there is a data given for crane loads, few values are always given. One of them is maximum wheel load. Okay. So maximum wheel load is CRV. So we can assume this value as say 150 kilonewton. Okay. Then we have CRVI. Okay. So this is nothing but as per IS code, IS 875. If you come to IS 875, some surge loads are given. I'll just show you. Okay. So this is given here. If you zoom it, vertical loads for electric overhead cranes. So this is the impact allowances. Okay. If you see this, impact allowances for the crane girders. For crane gantry girders and supporting columns, the following allowances shall be deemed to recover all the forces set up by vibration, shock from slipping or slings, kinetic energy action or acceleration. So this is the 25% of maximum static loads for crane girders for all classes of cranes. So this we have to consider 25%. So what is this value? This is nothing but CR VI factor. 25%. So this is not, we don't have to consider 25%. We have to actually add 25% in CRV. So CRV is, for our case, CRV is 150 kilonewton. So CRVI will be 150 into 1 plus 0.25. This 0.25 is coming from 25%. So we are going to multiply 150 by 1.25. So this is our CRVI. All right. So this is how you have calculated. Now, we have CRV already calculated. We have CRVI. CRVI is what? 150 into 1.25. So this can be 187.5 kilonewton. Now comes CRHS. So how much lateral surge we have to consider? So the code says that you can consider 10% for transverse. Transverse is lateral. Okay. Transverse movement is same as lateral movement. And when we are considering along the rails for overhead cranes, either electrical or so we have 5%. This is longitudinal. All right, 5% of longitudinal. So here this thing is also given in 875 probably. Let me just check. Okay, it is not given here. They are only mentioning that see IS 875 part 2. So we are already referring to IS 875 part 2. So this covers 5% of static wheel loads and 10% of weight of the crab. So this is important. We must note down only these two things. This is on page number actually 16. All right. So the lateral surge is 10% of the weight of the crab, and longitudinal surge is 5% weight of the crab, and the empty weight lifted by this crane, 10% of that. So this can be actually, you can take is the maximum wheel load and into 0.1 will give you 10% of the maximum wheel load you can take as the transverse or lateral loads, and 5% of the all static wheel loads you can take as the longitudinal loads. So let's come back to our calculations. And if I want to calculate the lateral surge, all right, lateral surge. So for lateral surge, what I will do is 150 into 0.1 gives me 15 kilonewton as a lateral surge, and CR HL longitudinal surge. This I will take as 150 into 0.05. So this gives me 7.5 kilonewtons. All right. So these are the values. Now what is CR park? CR park is a total empty weight of the crane. This can be any number. So don't get confused this with the maximum wheel load. All right. So maximum wheel load is what? So maximum wheel load is the maximum load that is coming on a single wheel. All right. This is called as maximum wheel load. So this maximum wheel load for our case is 150 kilonewton. Don't get confused. And what is the CR park? CR park is the empty load of this crane. Okay, this crane with all its part, including this crab, what is the empty weight when there is no loading? So that is called as CR park. Why we are, separating it? Because these values combine differently in load combination table. So we have to separate them. Understand? And one more thing I want to add for understanding that why these lateral surges and longitudinal surges or the longitudinal forces come at all. These basically come when this crane starts from the rest position or when it tries to stop. Then, when it is coming into an action, the force that comes in the lateral direction and in the longitudinal direction, see, when it is moving in this direction. So suddenly from rest to moving position, it will give a thrust to lateral direction, and when this crane as a whole is moving in this direction, so when it will apply brakes or when it will start, it will give thrust in this direction and this direction depending on the position where it is moving. So we have to be very cautious that which direction we are talking about, lateral directions or longitudinal directions. All right, so let's continue. So car park load, we can assume anything, and for just simplicity, we can assume the same value. Doesn't matter. We can say that our loading is say 130 kilonewton. Also, we can assume the empty weight of the crane. Okay. Now these things are clear. Let's start with the load combination table. Okay. So this is our table for load combinations. Now we will fill the values. First of all, let's have a look on what are the columns and what are the rows. So in this first column, we have load combination type. So these are the different types of combinations that we can create. Static, including dead load, SIDL only, and live load also if it is there. Then static and crane dead load. So what is the crane dead load? So crane park, CR park is crane dead. All right. So whatever values we are assigning in the model as CR park is what I'll explain you just after discussing this table. So these are actually CR park is nothing but the whatever is the empty weight of your crane, and you count the number of wheels and you assign per wheel the maximum load. There are 4 wheels. So if your crane has 4 wheels and your load is 150 kilonewton, so your per wheel load will be 150 by 4. So it will be 75 by 2, approximately 37.5 kilonewton, right? So you have to place this 37.5 kilonewton load such that it will create maximum bending moment in the supporting members. Supporting members means supporting, you can say supporting members means supporting beams, girders. So this should create the maximum bending moment in the supporting arrangements. Then this is called as crane dead load, CR park. Okay, when we are considering CR park, we are assuming that the crane is not loaded, it is empty. Okay, and when it is empty, then we can combine the CR park with other lateral loads like wind loads or earthquake loads. So this is important to notice. Now let's start filling this table and see these things. Also we can have a look. Static crane dead, static crane dead load plus wind. So this is static crane dead load plus wind. Then we have static crane dead load plus earthquake. So we have static, these are static crane dead load plus earthquake. Then we have static plus crane. In crane, we have imposed load, impact and lateral surge. So this is the static. All right. Then we have impact and lateral surge. Then next one, F. F is what? Dead load, static. Then we have impact and longitudinal surge. Then we have static crane, no impact, lateral and longitudinal. So we have dead load, static, no impact, plus this, plus this. So these are the combinations. Now what are the various factors for load combination that we will fill now? Now let's start. This is as per IS 800. So this is 1.5, 1.5, 1.5. Again, next is we'll also include the crane load. Then we have 1.2, 1.2, 1.2, then 1.2 and plus minus 1.2. So you have to take, see, we have to expand this combination, this one, C and D, based on the positive and negative directions of wind load and earthquake loads. Positive and negative plus X and Y. So when you have to apply wind in X direction, then you have to apply wind in minus X as well in the model. So there will be different load combinations. I am not expanding all the load combinations, but based on this information, you can actually expand it. All right. So there will be X and Y and positive and negative. So there will be 4 combinations for wind. Similarly, for earthquake also you'll have 4 combinations. If we are doing other, see, for earthquake, if you do 100, 30, 30 as per IS 1893, then you will have, and if you also include the Z directions, then for every load combinations, every means this is called as one set of load combinations. For every load combinations, we will need 24 permutations of load combinations of 100, 30, 30. For more details, you can refer IS 1893. If you need more help on the forming load combinations for 100, 30, 30 in as per IS 1893, then please do comment. I will try to make a list. Now again we'll combine one more load case for the wind, which is 1.5, 1.5, but no live load in this case. And here we have 1.5 and plus minus 1.5. Okay, then we have stability load case. Now we have earthquake. Similar to wind, we will make the same load combination for earthquake as well. Now we are coming to this one. This is imposed load, okay? Here it was a dead load. Here it is imposed load. So for imposed load, see these will be 1.5. Okay, there is no doubt about it. Now let's come to this side. When we have impact plus lateral surge, so we take 1.5 in impact and 1.5 in lateral surge. Then we have impact plus longitudinal surge. Then we have no impact plus surge in lateral and surge in longitudinal. So this is the load combinations. But you have to, take caution in case of earthquake loads. Each of these will form 24 combinations in case of 100, 30, 30. 24, 24, 24. Refer IS 1893 Part 1 2016 for more details on how to form the load combinations as per 100, 30, 30 combination system in earthquake load case. And for wind, you can refer IS 875 Part 3 2015. Okay, so these are the codes. Actually, I will mention it. It will be maybe useful for somebody. So this you can get from IS 875 Part 3 2015, and this you can take from IS 1893 Part 1 2016. So there you can get load combinations as per 100, 30, 30, and in 100, 30, 30 for each case you will get 24 load combinations. Here you will get 4 for each. Okay, so this is it for this today's lecture. And the purpose of forming this load combination is that, see, when you're applying crane vertical load, all right, on any wheel, at that point itself you have to apply uh, this thing, crane horizontal surge or lateral surge, and then you have to combine together. Okay, see, there are 4 wheels, no? So you're applying horizontal, you're applying vertical and lateral, all right? So you're combining based on this. Okay, so you have to assign load case properly so that when you're combining in load combinations, they should reflect properly. Okay, this is it about today's class or today's discussion. And if you like the content, please hit like and subscribe. Thank you.